All right. Computer Science Level 1 Blocks, Unit 9, Developing Algorithms. This is Lesson 4, Dynamic Castle Crasher Challenge. This is the actual challenge itself. In the Dynamic Castle Crasher Challenge, the VR robot must now knock all pieces off of each iteration of the Dynamic Castle Crasher playground. That means, and in the quickest way possible. So that means each time you reset it, it's got the same program needs to be able to clear it off just like this. Okay, so the learning outcome is you're going to apply logic of repeated decisions with multiple sensors to solve the Dynamic Castle Crasher challenge. So put it all together. Algorithms enable a user to create more diverse and efficient programs. Algorithms are precise sequences of instructions that can use selection and iteration to instruct the VR robot to use information from its environment to execute behaviors. Algorithms use loops to continually check sensor values and repeat behaviors. Nesting conditional statements inside each loop, such as a forever or a repeat until blocks, will instruct the VR robot to continually check those conditions. So in this case, we've got a when started, forever, check if distance found an object, drive forward, otherwise turn right. Selection is employed by using conditional statements such as the if, then else, or repeat until blocks to instruct the VR robot to execute certain behaviors depending on reported conditions, such as sensor values. Here you can see it's saying if it's found an object, it's going to drive forward. If not, it'll turn right. Using sensors with loops and selection enables a VR robot to interact with a changing environment, such as the Dynamic Castle Crasher playground. All right, in this challenge, create a project where the VR robot uses an algorithm to knock all of the building pieces off the Dynamic Castle Crasher playground in the shortest amount of time possible. I'm going to put a card in YouTube. I'm going to put a link to the video that's already, I think it's got like 10,000 views or something. A lot of people have watched it already on the Dynamic Castle Crasher playground that I did when it came out. So I'll put a link to that. Solving the Dynamic Castle Crasher challenge requires the use of a timer. You can use a stopwatch, a phone, or you can even use the timer on the VR robot. So that's probably the easiest thing to do. Is you just go into sensing and you click that little box and then you open up monitor. I'll show you that here in just a second. Follow these steps to complete the challenge. Create a new project or load a project from previous lesson in the unit. Rename the project Unit 9 Challenge. I'll copy that so we can do that. Launch the playground window. Load the Dynamic Castle Crasher playground. Add the blocks necessary to drive the VR robot to push off the building pieces off of the playground in the shortest amount of time. The VR robot should not fall off the playground. Okay, start the project. Test if it works. The algorithm should work regardless of the layout of the playground. Document the time it took to complete the challenge on a piece of paper on your device or by monitoring the timer in VEXcode VR. Continue to revise and run the project until the VR robot successfully completes the Dynamic Castle Challenge in the shortest time. Save the project and until it successfully knocks them off. And congratulations, you have successfully completed it. Let's look at the lesson quiz, but before we do that, let's go over to the VR playground. We can see here, this is the program we had from the last lesson. And this program almost works. So if we go ahead and up here, I'm just going to change that to, there we go, and rename. So it's Unit 9 Challenge. I'll click Start. And I'm going to probably need to make some changes, especially if I want it to go fast. I want to go fast. So if I want to go fast, I'll probably go to Drivetrain. And the first thing I'll do is I'm going to set the drive velocity right here. I'm going to set that to 100%. Make that guy move fast. And the turn velocity, I'll leave as 50% right now. Okay, so it's almost knocking stuff off. Oh, but oh my goodness, it's like, it's jittering. Okay, it did knock that off. I don't like the 90. I think turning 90 is causing it's turning too much. And I don't like the backup 300. So let me change that back up to 200. And I'm going to change it to 45 to turn 45 degrees instead. And then that with the 100% speed, boom. And let me show you. So you go under sensing. This is where we get the timer. We go to sensing and you click timer in seconds. And then when you open the monitor, you'll see the amount of time. But you can also see it down here in the lower left. So they added this timer down here after they wrote the lesson, I think. So, you know, you can use either one. They both work the same. Hey-oh, boom. This one looks like it might work. Okay, but I know that it can be improved upon. I know that. You might, this one might also run off the playground. Or it might not ever get to those over there. And see how it jerks like that? Like it pushes and then it turns a little bit. That's slowing it way down. So there might be something you can do to prevent. I know there's something you can do to prevent it from doing that. So I'm going to leave it there and show you. So it looks like I'm over a minute. I think I cleared it in like in the video. It's been a while since I've seen it. It's a few months old. That video, I think I cleared it in like 20 or 30 seconds. Now, I'm going to give you a warning about that video though that I linked. I should have given you that warning before I told you about the link, is that they updated this playground. So if you copy my code from the other video, it probably won't work. All right. And I didn't update it on purpose because the whole process of this is a learning process. And look, I fell off. So you're going to need to adjust this, that 45 degree change or make it back up more. You're going to need to experiment with some trial and error. And the same thing with the other code. You can look at what I did in the other video and determine if that will work for you. Or at least you can get inspiration from it. But the code itself, the direct code itself, probably won't work. Just fair warning. All right, let's look at the lesson quiz. Let's see how many questions there are in this one. Oh, just one. Okay. This project was used to knock all buildings off the dynamic Castle Crasher playground. So you get some inspiration here too, right? But it does not work correctly. Which of the following best describes the error in this project? Well, the first thing I notice is if it gets to here, it's done, right? It's not going to do anything past that. So let's see. The VR robot needs to use distance sensor. Nah, and there's no walls on this one anyway. The entire project needs to be nested inside a forever loop so the condition of the if then else block are continually being checked. That's probably B. Let's take a look at C and D just to make sure. The drive block should be replaced with a drive 4 block. The VR, and that's another thing. You could try that. I would say this is not the correct answer. C is not the correct answer, but you could try a drive 4 block. You could say drive for 50 millimeters. It might cause it to drive off the edge. It might not. You could try it. I wouldn't try like 200 millimeters, but the repeat until block should be replaced with a wait until block. Now, we already covered that in the last lesson. We would use a repeat until, not a wait until. So everything is right. It's just they just need to put this whole thing in a forever block. All right. That's it, guys. And that concludes the computer science level 1. If I click next here, I'm going to get to the unit exam. I am not going to review through the unit exam for unit 9. You guys go ahead and do that. If you have questions, feel free to put them in the video. Okay, comment in the video, and I'm happy to assist you guys. I hope you don't notice any of those of you guys that have been commenting. Hope you notice that I do check the comments and I do respond. I try to respond like within 24 hours or less, but sometimes it can be a little longer, but I do respond. Okay. So, and if you have a question, go ahead and ask it, because somebody else probably has that same question, and that'll help everybody out. All right. Well, I've really enjoyed Computer Science Level 1 blocks. If we go to the Computer Science tab of education.vex.com/STEMlab/CS, we'll see here that Computer Science Level 2, transitioning to text, it says coming in 2021. That's exciting. Hopefully we'll see this. I don't know if we're going to see this in the 2020-2021 school year, or if we won't see this until the 2021-2022 school year, but the plan is that they're going to release this, and this will help transition to text. If you are hungry to start learning some text, though, I do have a playlist for VEXcode VR Python. Python is the name of the programming language that is the text-based programming language. So instead of blocks, it's text. You type it out. That is the name of the programming language, which is really cool because Python programming language can be used in all different kinds of applications. So it's something that if you learn, you could really potentially use that in the future, in a job even in the future. Okay, so thanks so much, guys, and this was a blast, and I look forward to going through more of these lessons in the future. All right, have a good one.